I'm Mike Greiner. I'm the president of Hazard Control Technologies and one of the 4 members on the development team of the encapsulator technology that we brand under different names. I want to personally welcome everyone here, and thank you to Mr. Karajoki. Mr. Karajoki is the managing director of Okama Affinity, and Okama Affinity is HCT's exclusive distributor in Nigeria. But Mr. Karajoki is also the business partner of HCT under Hazard Control Technologies Nigeria Limited. And we put together that company with the purposes of creating a fill-up factory right there in Nigeria that we can ship product throughout all of the continent of Africa. So, I'm looking forward to us getting to the point where we build that fill-up factory and start expanding into the other countries. Our mission here is to encapsulate the world. And again, welcome you. This is a slide on Okama Affinity, our business partner over there with offices in Abuja and the Warri Delta State. And again, I already mentioned that also Mr. Joki is a business partner of ours under HCT Nigeria. Today, we're going to talk about encapsulator agent on the lithium-ion battery hazard. But before I dig into that, the F500 encapsulator agent is used for a multitude of fires. It's also used for vapor encapsulation and explosion prevention systems in the oil industry. So why wait till we have an explosion and we have a fire when we can actually encapsulate those vapors and prevent the explosion? So it can be very proactive in that market. Also used for flammable liquid spill control, it's used for environmental bioremediation, and we have uses in other applications, including agricultural type uses outside of just the forest fires. But today we're only going to focus on this lithium-ion battery hazard. And the lithium-ion battery is becoming the #1 growing hazard in the world. And it's because the lithium-ion batteries work so effectively. So if you have your Samsung or your iPhone, you'll notice that it goes and it goes and it goes, and all of a sudden you get a notice 10% left, and then you get a notice 5% left, and about 1 minute later it dies on you. Well, that's why they're so popular. The older batteries, you would start at 100%, and as you're using them, it goes to 50%. You get 50% power, then it goes to 25. You only have 25% power in your power tools. But with these lithium-ion batteries, it stays at full 95 to 100% power all the way up to the very end, and then it dies. So you get much better use out of these batteries. So you have an anode side and a cathode side of the batteries, and you get an exchange of these lithium ions, and that's hence where it comes from. These batteries are actually quite reliable, but when they do catch on fire, there are some major issues with extinguishing them. So like I mentioned, they're everywhere. We continue to grow. They're very diverse. So we're seeing lithium-ion battery cars, lithium-ion battery fire trucks, lithium-ion battery is everywhere. The batteries emit toxic gas that comes off the flammable electrolyte. We're going to talk about how our agent helps to lessen that. And they are very high energy density, which I just mentioned, which is why they're so popular. These batteries are actually contain plastic coatings, which are A. When they melt down, the plastic actually becomes a B. type fire. We have the electrolyte in the batteries, which is flammable. We have actually run tests with some of the big electrolyte providers like Panasonic to demonstrate that this encapsulator agent actually encapsulates the electrolyte. We'll talk more about that. And it's energized, so you can get a shock potential from extinguishing the batteries. So this is how these fires can start. You can short circuit the batteries. You can have trauma like drop the tool on the ground or your iPhone, laptop on the ground. You overcharge the batteries, can cause overheating. And typically that's one of the ways that when we do destructive testing and fire testing, we just overcharge the batteries. And then overheating the batteries. I don't know if you ever put your cell phone up on the dashboard of your car, it gets really super hot, and that can lead to a fire. Here we have just a quick news story. Into flames. Police tell ABC News it appears no one was in the driver's seat. Here's ABC's Gio Benitez. Can we hear that all right, Hernan? Deadly crash near Houston.
Yeah, Mike.
Model S. The charred wreckage captured on camera after it crashed into a tree and burst into flames. You can see there's not much of the car left. Tesla's high-energy battery reigniting over and over again. Firefighters trying to put the fire out for 4 hours with more than 30,000 gallons of water. The fire eventually put itself out. Now tonight the question, was the Tesla running on autopilot? Firefighters found the man in the front passenger seat and the back seat. Police telling ABC tonight to the dead. So the rest of that story is talking about the firefighters, but the key things, was the whether somebody was driving the car, it was on autopilot, but 2 people perished in that crash. But the big things to take away from this crash is firefighters used 30,000 gallons of water in an attempt to extinguish that. Well, that's 30,000 gallons of runoff, and you'll see later that that's just not water that's running down the storm drain, causing an environmental issue. You can see these fires are highly explosive in the beginning, put off a lot of gas. Quick video showing F500 rapidly extinguishing the battery. I want to point out that, our company has been engaged with the lithium-ion battery hazard since the year 2008. So we're not coming to you presenting F500 on the basis of one test. F500 encapsulator agent first started the testing with Bosch, who's one of the leading manufacturers in the world of lithium-ion battery, and they tested dry powder, foam, wetting agents, nitrogen, CO2, and F500 encapsulator agent. They have standardized on the F500 encapsulator agent. That testing led to multiple additional testing around the world. It's led to a standard in Germany and some additional things you'll see here. So again, what we're representing isn't just, oh, hey, we got lucky and put out one battery. So chances are that you use batteries in your daily life, and they're found in every industry. They're found in every commercial building. So here I just show some of the transportation industry. So we have the hybrid vehicles, charging stations, parking garages, railroads. People don't think about railroads, but they either hauling a lot of lithium-ion battery, or some of the maintenance equipment at the rail yards are lithium-ion battery, welding robots, repair, towing companies. So you look around, a lot of people see this, but you don't necessarily see some of the equipment in the background that's being used to fix and repair these cars. Buses, even the fire trucks nowadays, all of the equipment on the fire truck, including extraction, is all going to lithium-ion batteries. So while the fire department's coming to put out your hazard, which is lithium-ion battery, they're carrying that hazard right on the truck as well. So you can see you're getting a buildup and some off gas. You can see that this one's now on fire as well. So the fire from the first one has propagated to the next one. This is just rolling down the road. We see an electric truck fire on the opposite side of the road. You get the idea. I mean, that fire, that truck fire with the lithium-ion battery was like fireworks. The aviation industry, loading devices, ground hauling equipment, parking garages, forklifts, backup systems, radar systems, consumer electronics. Sorry, let me go back. These are, it's not just the airplane, it's all the equipment that's now servicing the airplane is lithium-ion battery. I know that Turkey Department of Aviation just purchased F500 and has put it at every one of the 48 airports in Turkey and 3 private airports. So it's at 51 different airports. And the purpose of the agent that they're using it for is fire protection of all the ground equipment and for flammable liquid spill control. And if they have a specific hazard on an aircraft, they'll use it on the aircraft as well. So here's a little runway fire from Alliance. Sorry, that might be Air France. You can see they're squirting a lot of dry powder fire extinguishers here, but it's absolutely 100% ineffective. I don't know how expensive aircraft are, but you're going to lose all the avionics, everything in that entire aircraft because we couldn't put out one simple lithium ion battery fire. Part of, I think, the issue that we see worldwide is the lithium ion battery is currently classified as a Class A fire under the NFPA codes. I know European is looking to classify this as a Class L to separate it out. And the reason for that is because your typical things that work on Class A fires do not work on the lithium ion battery fires. So there's certainly a need to separate this hazard into its own classification. We are also seeking to work with NFPA to have a new classification. Some consumer electronics, cell phones, laptops, battery backups, power tools, iPads, hoverboards, e-scooters, remote control toys, even your remote control for your television, gaming consoles, all of these things contain lithium ion batteries. So everything we're talking about here that's business related, warehouse related, commercial buildings actually also applies to your home. I have some of these at my house. I have a lot of this stuff at my house. I also have an F500 fire extinguisher at my house because I know how effective it is. Here's forklifts. It's not just the forklifts and the forklift charging stations. It's forklifts as they're moving around the facility. Here you can see an e-scooter. The guy's like, oh, what's going on? Is it a problem over here? And then all of a sudden you get this toxic off gas and everybody's running. No, that fire right there is easily extinguishable with an F500 fire extinguisher. There's no reason to have the whole house burned down. You can see these are pretty violent reactions. These are, the fire is in thermal runaway. It's propagating from one cell to the next cell to the next cell. And will continue until all of the material is exhausted. One of the nice things about that is it does open those cells up to allow the F500 in. Well, that battery doesn't look like it's that big. Your fire department may come out and need 2,000 gallons to put that out. So if that is in a more rural area where you have a truck that carries 500 gallons, you now are needing to deploy 4 or 5 fire trucks to the scene to do something that an F500 fire extinguisher could extinguish. Energy storage systems is a very big growing market. So what's happening here is we're all trying to go to green energy. So we're either going to solar panels or the wind energy, and that energy is being put into lithium ion battery energy storage systems. So these are 40-foot containers. They have rack storage inside. They get charged up all day long. They get charged up at night with the wind power, and then during peak hours, they get discharged. Here in the US, we've termed something called power shaving. So we use that power during the peak periods and then recharge it at night. These are quite expensive. Each one of these units may run anywhere from $500,000 to $1 million or more. And when they catch on fire, if you don't extinguish them, you're going to be out 1, 2, 3 million, maybe more if you've got all these lined up together. I know there's a new NFPA 855 code for energy storage systems. It's going to be released in February. And there's a whole section in there on fire protection using encapsulator technology. Here in our medical industry, all kinds of different things that are using lithium-ion battery. Mining is another industry using lithium-ion battery. This is a warehouse here in the United States. This is actually up in Wisconsin, which is one of our northern states. You'll see the forklift, boom, catches on fire. Fortunately, the guy jumps off and runs over here. So here he is over here. Now he's going, let me get my ABC dry powder fire extinguisher. Now, I'm sure that when he jumped off, he wasn't thinking about, oh, maybe I better put the brake on. I wouldn't be thinking about that. I'd be thinking about, let me get my butt off of this forklift. So here he comes with the dry powder. You'll see some people running in from the left side here. You can tell who didn't attend fire extinguisher training. This first guy started to disperse way too soon, but now we have a number of dry powder extinguishers. 1, 2, 3, 4, 5. This guy here is going to be 6, trying to put this fire out. Looks like they got it, but then whoops, we just thermal run away to the next cell. And here towards the end of the video, we're going to be able to see this forklift starting to roll away. So there we see a forklift fire that could have been extinguished that actually wasn't, that got rolled away to an area in that facility that burned the entire facility to the ground. $250 million of loss. Well, the insurance company has now connected us with that particular customer, and they're utilizing F500 encapsulator agent at every one of their facilities. Even though currently the NFPA code classifies this as a Class A, and they have ABC fire extinguishers, it's evident to them and anyone who watches the video that an ABC dry powder doesn't work on this. So you are not prepared. You might think you're prepared, but you're not. So now they put F500 fire extinguishers at their facilities. They have 9-liter, 25, 50, 75, and 100-liter wheeled units at all of their facilities. And it's a major US company. Here we can see buses in China. China is now adopting F500 encapsulator agent as their go-to product for lithium-ion battery. This is just some notable headlines. These are major things that make world news. Burning power bank. That's Airbus. Here's Arizona Energy Storage. This has gotten a lot of attention here in the United States because that had an FM200 system inside the container. They thought extinguished the fire. When the firefighters opened the container doors, it let air in. The air mixed with the explosive gas. The batteries were not extinguished. They resulted in the ignition source that caused an explosion. It threw one firefighter almost 75 yards, 25 meters away and into a fence. So they had several career-ending injuries with this particular one. This has gotten a lot of attention. You can see NFPA, UL, FM Global, all the people analyze what went wrong here. And quite frankly, some of the NFPA 855 committees addressing some of the issues that went wrong here with encapsulator technology. So the question is, are you prepared? We've already seen some dry chemical. It's inefficient at cooling. It doesn't prevent any reignition. In fact, from what I saw with dry chemical, it never puts the fire out in the first place. Doesn't do anything for the toxic reduction, and it's just not effective. And this is the problem, because pretty much every commercial building you go to, at least in the US and most likely worldwide, has a dry chem ABC fire extinguisher by code. Yet we have all these cell phones, all these iPads, all these laptops there that will start a fire, and this won't put it out. And then that fire will grow bigger and bigger and bigger before the fire department comes. When they arrive, they're going to put copious amounts of water on that, causing even more damage. So one very simple fire that could be addressed is going to cause major type of damage at your facility if you're not prepared. So these are fully charged. Here we're going to see dry powder. And you can see that it's just not effective at putting this out. And this is an ABC extinguisher. And here you have A because you have plastics, you have B, plastics and electrolyte, C, it's energized, and in some cases you might have some class D materials, but even an ABC fire extinguisher is not capable. This is the main reason we want to try to get NFPA to classify this as class L in its own separate class. Again, foam, let's take a look at foam. It's ineffective to cooling. It blankets and retains the heat, which is actually aiding in that reignition. There's no toxic reduction using foam, and it's just not effective. And here we'll see the foam. This is testing that was conducted by Kiwa, which is a testing lab in the Netherlands. And they tested this on behalf of Tesla Europe. So Neuropene, who is a division of Johnson Control, and Johnson Control is the largest single fire protection supplier in the world. They own Tyco, Ansel, ChemGuard, Williams Fire and Hazard Control, Simplex, Grinnell, York, and a whole bunch of other brand names, including Neuropene, who is a fire extinguisher manufacturer in Germany. Well, Neuropene was trying to sell Tesla fire extinguishers, but they required a certification. And because of the reputation of F500 in Germany, our largest competitor in the world elected to test F500 in those. And I'll talk a little bit more about that later here in the presentation. So inerting gases, again, inefficient, can't stop the reignition. We saw the first part of this video. And here they're coming in with the CO2 inerting gas. Totally discharged it. I actually come back with the second one. He extinguished it. But you'll see you still have burning going on, and we're still seeing a bunch of off-gassing as soon as this cloud, you can still see right here, a bunch of off-gassing. So it hasn't addressed the thermal runaway. Water. Here currently, the NFPA is saying, hey, you use water. We haven't found anything else that will work except the F500. So here, when you use water, it's ineffective in cooling. The reignition is not, it doesn't stop your thermal runaway. Again, we're looking at all aspects of the fire. We've already seen the video on this Tesla crash. They used 30,000 gallons of water to extinguish this. Well, when the water reacts, hits the lithium ion battery, it creates hydrofluoric acid. So you don't just have 30,000 gallons of water running down a storm drain. We have 30,000 gallons of hydrofluoric acid going down there. That is a huge environmental issue. That's a huge environmental and costly cleanup. And some of those things currently aren't being addressed, but I am sure the US EPA here is going to start getting on somebody, whether it's the owner of the car, the insurance company of the car, or whether it's the fire department to hold them responsible for putting 30,000 gallons of hydrofluoric acid down the drain. So this just shows what's happening. You get some external damage, fault, safety management system starts overcharging. You get thermal runaway. You end up with temperatures above 850 C. You know, a strong cooling effect is needed to put this fire off. You get a significant hydrofluoric acid emission on the runoff, hydrofluoric gas on the coming off, and then it becomes self-heating for up to 3 weeks. So, you know, these can be very challenging fires. So let's talk about our F500. F500 is 100% fluorine free. It's non-corrosive. It's 100% biodegradable encapsulator agent. So F500 is not foam. It's a multi-purpose agent. It's currently UL listed under NFPA under Class A and B fire suppression. Now, there is a new standard that's going to be published in February of 2022. So it's only 3-4 months away. I sit on that technical committee, and we added a chapter to that standard to be able to test and get a listing for Class D metals, because we know our agent is effective on A, B, D fats, which F in some parts of the world, K here in the US, and lithium ion battery. It's also a combustible, flammable, vapor, and liquid spill control agent.
Encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head, which loves water, dissolves in water, and a hydrophobic nonpolar tail, which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet, with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet. Encapsulator technology within each droplet.
You want to stop here for 1 minute, so that you can understand what we're talking about. We all are familiar with foam. Foam is a thin wall bubble structure, and we put lots of bubbles together to create a foam blanket that will mechanically separate the fuel from the oxygen. The encapsulator technology or encapsulator agent is based off of spherical micelle technology. So here we're forming these spherical micelles. Think of these as molecular chemical cocoons, molecular safe. So what we're doing is we're putting the fuel, whether it's a carbon or hydrocarbon molecule, inside this spherical micelle, inside the spherical or the molecular safe. And what we're doing is we're separating the fuel from the oxygen on a chemical molecular level, as opposed to foam that's doing it on a macro mechanical level. One thing I mentioned in that video is once the agent goes into the water, we instantaneously and automatically form those spherical micelles. That is way different than foam. Foam is so reliant on the equipment to push air into it and generate that, depending on the equipment, depends on the quality of the foam that you will get. Not the case here. The spherical micelle is the same every time. So it makes a very consistent fire suppression medium. So this is the simplified depiction of the molecule polar head. It dissolves in water, loves water. I always remember polar bears love water. That's how I remember this part of the molecule loves water. The nonpolar tail is hydrophobic, fears water, like claustrophobic, arachnophobic. So it's going to do anything it can to get away from water. So the minute it goes into the water stream, it forms these spherical micelles. Now, we've blown these up so that you can see them. These spherical micelles are actually measured molecules in terms of angstroms, 1 × 10⁻10th. It's really cool to look at these under a high-powered electron microscope. So what's happening here is you have all the micelles already in the hose stream. As a droplet forms, you have all these micelles already in the droplets. The ones closest to the surface break apart, so that non-polar tail that hates water sticks out. It pulls this polar head to the surface, and we form a skin on the surface of every droplet. So we're physically changing what's on the surface of every droplet from a water molecule, an H2O molecule, to an F500 molecule. In addition, if we cut away the droplet, we're seeing millions of molecular spherical micelles inside. And these micelles perform 3 major functions in the fire suppression area. The first one here is encapsulation. Spherical micelles encapsulate carbon and hydrocarbon liquids and vapors. So it doesn't matter if those are in the liquid phase or the vapor phase. We're separating the fuel from the oxygen, rendering items non-flammable and non-ignitable. So we're not just simply putting a bandage on it like a foam would be just a blanket bandage. We're providing long-term burn back resistance. So we know the electrolyte is flammable. So what we're doing is we're encapsulating that electrolyte inside the spherical micelle, separating the fuel from the oxygen. But we also encapsulate toxic off gases. These are things that will cause people to become very ill and have to go to the hospital. We also encapsulate explosive off gases. This is one of the main reasons the NFPA 855 committee is looking at this agent, because on that job in Arizona where they used FM 200, it did nothing for all the explosive off gases. So when the firefighters opened the door, boom, major explosion. If you encapsulate those explosive gases inside a spherical micelle, we're separating the fuel from the oxygen and taking away that reignition and explosion potential. So that's one of the things. The second thing that the spherical micelle does is it actually changes the heat reduction mechanism of the droplet. So instead of steam conversion like you get with water or foam, you are changing that to what's called thermal conveyance. We're actually driving the heat into the internal portion of the droplet, and we get 20 times better heat reduction for the same volume of water than you get out of foam or water. And we have a lot of independent testing showing that. What's the result? Well, the result is this was on fire. You extinguished the fire, but because of that tremendous rapid cooling and effective cooling, we're able to cool all of the stuff over here that didn't catch on fire and actually prevent thermal runaway. So we're doing two things. We're encapsulating any exposed electrolyte so it can't reignite. And secondly, we are reducing down the temperature very, very rapidly. And we have some high level, highly instrumented, highly documented university level testing from Germany showing that. Toxic reduction. The third thing that the free radicals do, excuse me, the third thing that the spherical micelle does is it interrupts free radicals from coming together. It's called coalescence. When free radicals come together, they form toxic soot and smoke, and we inhibit them from coming together. So we significantly reduce down the toxic and sooty smoke from creating. But we also know in this particular hazard, it emits toxic fluoride gases, hydrogen fluoride gas, which is bad. And tests show that when we use F500, these are drastically reduced, and they're drastically reduced because A, we're stopping the thermal runaway, so producing less gas, and B, actually encapsulating the gas that's coming off. So we got rapid cooling, we're stopping thermal runaway, we're encapsulating the electrolyte, we're encapsulating toxic gases and explosive gases, separating the fuel from the oxygen, separating the toxicity from the humans. We're reducing that toxic gas, and it's highly effective. So let's just kind of take a comparison here. This was the testing done at Kiwa. Here we see the three mediums, the dry powder, the foam, and the F500. Sometimes people focus on the dry powder and foam and don't even notice the F500's already extinguished the battery. It's not magic, it's applying the spherical micelle technology to the fire. This testing here was actually conducted at Kiwa in the Netherlands, and it was conducted on behalf of HCT Europe. We have offices in Frankfurt, Germany, so, and Johnson Controls. And again, Johnson Controls is the largest competitor of ours, friendly competitor, I would add, but they're the largest single fire protection supplier in the world. And they ran these tests because Tesla Europe said, I need a certification. In order to run these tests, Norapine, who makes the fire extinguishers, had to solicit the mother company, Johnson Control in Europe. Johnson Control had to solicit and ask the mother company in US, can they do it? And the US said, yes, you can test F500. However, you must also test everything that Ansel, ChemGuard, and Williams Fire and Hazard Control make. Understand that Johnson Control is the largest single foam manufacturer and supplier in the world. So we were invited to day one where they tested F500. We were not invited to day 2 and day 3. They did 3 days of testing. On day 4, they contacted us to engage in a commercial partnership to joint venture an F500 fire extinguisher with EN3 list ratings. So these were the results here. The dry powder, pour, do not apply on lithium ion battery. You're just wasting your time. Foam, moderate, pour, moderate, not recommended to apply. And the F500 was sufficient, and sufficient. Excellent, excellent, excellent. Can be and is recommended for lithium ion battery. Like I said, on day 4, they approached us. We've got a partnership going on together in Europe. We make fire extinguishers. We have a joint listing marketing agreement. So these were just some of the results. And they said during the test here, we dropped very quickly below 150, which is regarded to be the temperature where thermal runaway is eliminated. So Johnson Control has come out and they have a brochure. It's not a part of this presentation where they're pushing and promoting lithium ion F500 on lithium ion battery. We did testing on various types. This is the pouch style like you find in iPads, iPhones, computers. You can see the F500 very quick to extinguish. One thing I point out here is you have fire up underneath here. Even the F500 didn't touch it because of its tremendous cooling capabilities, was able to remove the heat leg of the fire tetrahedron and get rid of the heat, get rid of the fire. Another patch. I want to point out here that what we're starting to see are fixed system applications. So this piece of pipe leads back to 50 liters of a 2% solution, and it's feeding these 2 European water mist spray nozzles. The reason we've gone to this type of configuration is because the Kiwa test, the guy who was doing the firefighting on the lithium ion batteries with the fire extinguisher, he did 3 days of firefighting. He was exposed to the HF gas and they had to transport him to the hospital to detox for 1 week in the hospital based on his exposure to the HF gas. After that, we said, okay, we need to start applying this agent, especially if we're doing repeatable tests, we need to apply it using no humans. So instead of human interaction, we've got these highly instrumented and highly documented. This one here is being overcharged. This and the next one catch on fire. There's actually three pads in here. You can see it's the second one up here that's catching on fire. Which in turn caught the first one on fire. I think the significant thing here is the third one never catches on fire. We're able to reduce the heat, stop the thermal runaway, stop the propagation to the third pouch. This is a test that's run at Fraunhofer University. Here in the US, we would equate Fraunhofer University to MIT, which is a big time engineering school. So we can see we have 18 650 cells. It's going to overcharge with these glow plugs. These wires coming off are thermal couples that are placed within the battery's structure. So all different events. It's equating to these 8 thermal readings here. We have thermal imaging looking at it. Up here is the two nozzles. This goes back to 50 liters of a solution of F500. And up here, you can just see a different view, a side view, and this is a top view. So let me start this. It takes about 3 or so minutes as we start watching these temperature readings over here. They start to go up. We're just starting to see some increase here in the temperature. Eventually want to focus here on thermocouple number 3. It'll get up to about 800 degrees Celsius. And then after we start to extinguish within seconds, it goes down to 36 degrees. Let's move this forward. And again, if you put your name and your email address, if you registered through the Constant Contact, we have it. If Karajoki sent you the link and you just signed in using the link and didn't go through the registration process, we're recording this. You can have this presentation and the recording. You just have to put your name, company name, and email into the chat, and Mr. Hernan Dominguez, who is the host here today, will make sure that you get this information. So we can see the flame up here. We can see the thermal imaging lighting up. Here's number 3. It's at 240. Number 1's up to 300 C. Move forward to about here. Here we're up to 819, 800, 700, 720. Right about here is where it starts to discharge. So it's fluctuating up and down. You might take a quick gander here as soon as it starts to discharge. And you can easily see right here when it discharges, because it's a matter of seconds, that's going to drop down to 36 C, and then it drops immediately to about 16 C. Okay, discharged. It went down to 360 and then 36. Now it's down to 19. Now it's off the charts, can't read. So you can see how fast this takes that temperature down to prevent the thermal runaway. In the meantime, as we're doing this, we're encapsulating the electrolyte, explosive off gases, and this toxic HF gas emission. So this chart is showing us that with plain water, we're picking up. So let me back up, because each of these tests we would do with plain water, and it would not extinguish the fire. And then we'd come back with the F500 and it would extinguish the fire. So we have the data from the water and the data from the F500, and that's what we're seeing here. With water, we're not getting any extinguishment, and the parts per million of this HF gas is ranging from 200 to 2,600 parts per million. If we look down here, the acute exposure guideline for humans is for 10 minutes, you can be exposed up to 95 parts per million. For 30 minutes, only 34 parts per million. 60 minutes, 24, and 240, only 12 parts per million. Well, if we're using water to try to extinguish these fires, because we know dry powder and foam doesn't work, well, we're being exposed to anywhere from 200 to 2,600 parts per million, which is way above even the 95 for a 10-minute exposure. So these batteries can be very dangerous from a health standpoint to anybody trying to fight these. So we want to extinguish quickly and encapsulate this HF gas. So this is showing with the F500, these first two are pouches, and these are the 18650 cells. This is like what you find in your Ryobi batteries and for your power packs and tools. These are iPads, laptops, and iPhones. Um, but here you can see we quickly drop that down to under 2 parts per million. So not only is it safe in a 10-minute environment, but well up to 4 hours here without getting that toxic exposure. That's very important to firefighters, very important to any arson investigation that needs to come in and take place, is that we're really scrubbing that environment. The other thing I mentioned is when you do water, you create hydrofluoric acid runoff. That does not happen with the F500. Why? Go back and think about our droplet. We don't have H2O on the surface interacting with the chemistry of the lithium-ion battery that creates the hydrofluoric acid runoff. No, we have the F500 skin on that droplet. So the F500 does not interact with the chemistry of the battery to form that. That is a huge benefit for anybody on a cleanup. For example, using plain water in Germany, they have to contain and clean up, cost about €100 per cubic meter of disposal. So a cubic meter might be 1,000 liters. So each 1,000 liters costs $100. They eliminate that. Not only do they have less, because with water you need copious amounts of water, so you have copious amounts of disposal at a thousand, well, about $1 per liter. You eliminate that and have minimal with the F500. So the solutions that we have, we look at a 360-degree approach here. Education. Our aim is to educate companies, employees, fire departments on the lithium-ion battery technology and the hazard. This battery is not going away. As we see in the earlier part of the of the presentation, it's growing and it continues to grow everywhere. Training, we provide training on lithium-ion battery and will help you approach any incident with confidence. The encapsulator agent. The F500 is the agent of choice by many people, Bosch, Tesla, and many others. And as this education spreads and the understanding of what's happening with encapsulator technology, that continues to increase. Even Johnson Control, who again is a friendly competitor, yet they are our largest competitor in the world, has embraced that F500 is the agent. I asked myself one day, why would you do that? And when I was talking with the Johnson Control higher up management, they said, we pride ourselves in bringing good, viable solutions to our customers. And we don't have a good, viable solution. You have it. So we have two choices. We can either A, turn our good customers over to you. I'm talking about Volkswagen, BMW, Audi, those type of people, turn them over to you for their lithium-ion battery, or we can embrace the technology, keep our own customers, and provide them solutions that work. I thought that was a very thoughtful answer as to why they're partnering with us. And again, equipment, we offer a wide variety of equipment. So here we have mobile equipment, including 2.5 gallon, 9 liter, 6 liter fire extinguishers. We have these quick attack mobile units that are wheeled units, 25, 50, 75, 100 liter. Well, we have carts. These are carts that can hook up to your standpipe that have a built-in eductor. They can hold 100 or 150 liters of agent. So remember, you want to go back here and I go, well, why would I need a cart if I can extinguish this with so quickly with F500? Remember, F500 is, I'm only talking about this one hazard, flammable liquid control, class A, class B, three-dimensional class B. There's a ton of applications in addition to lithium ion battery. So we do fixed systems. We have three different types. We have bladder tanks, water driven proportioners, and pump systems. This is to proportion the agent into your riser pipes so that you can use this in a sprinkler type application. Um, the bladder tanks are anywhere from 36 up to about 2,000 gallons. After that, we would go to these. These are called water-driven proportioners. So it's plumbed right in line. The water's going through here. It's turning a wheel. That wheel is turning a gear, and here's the agent. So this is kind of like a fuel injection system. It injects the agent right into your water stream. This, excuse me, is a wonderful device because it operates through a very wide range of flow, and you get super accurate proportioning. So if you have a closed head system and three heads open up, then you might be flowing somewhere around 30 liters per minute. And if 10 are opened up, you're now flowing 100 liters per minute. And so it will proportion very accurately through those. So we work with the local design, build, fire protection contractors who install. And what we provide is they provide us the design of the flow through this pipe and the proportioning and how long we need the proportion agent. And we'll provide them our HCT diamond doser, the agent, the holding tank, and this type of piping in between the holding tank and the agent. So we do that. And then after the equipment's installed, we provide an on-site commissioning, startup, and certification service to confirm that it's actually operating right and proportioning correctly. That's what this little thing is here. So the water flow is coming through here. This is plain water. Agents coming in here. It's being proportioned. And then here it's going up to the riser, and we have a little port built in where we can pull a solution sample and verify the proper percentage. This is just showing you some systems. This is a bladder tank system. So inside here is a rubber neoprene bladder that's compatible with the agent. And as the hazard discharges, a valve, automatic valve opens up, and the agent comes out here and goes up and is proportioned into a ratio controller. This is actually systems from Tesla. So these protect their rack storage, their charging stations. We've signed NDAs, so I can't really send all the details, but let me describe that they have 4 rows of racks of lithium-ion battery charging station. Each row is 5 high and 25 long. So there's 125 batteries that are being charged on this row, and 125 on that row, and 125 here, and 125 there. So you got a total of 500 batteries. These are Tesla car batteries being charged in this room. And if there's a battery fire, they will discharge the F500 on it. I'm aware that they've had 3 fires. The only reason I'm aware of it is because we've gone back to do the commissioning and refilling the tank, but the public's not aware of it because the F500 was so effective to put the fire out. It didn't make the major news story. And I think that's what a lot of people like, is let's stay out of the news. We also have partnered up with this company called Fire Rover. Fire Rover has a system here that has a monitor on the top. So the nozzle, we can't see the top of this, but at the top of this, there is a video camera, a thermal imaging camera. It's a military grade camera, and it basically feeds to a monitoring station. So these facilities that have this are monitored 24 hours a day, 7 days a week, 365 days of the year. This is a very unique application. And so they're constantly moving the camera around. There is a live body. The feed is going to a monitoring station. They monitor it when a thermal imager detects a fire from the remote facility. They can go ahead and discharge. Inside here is 1,000 gallons of water, 30 gallons of F500. The F500 is discharged into the water, creates a solution. Then that solution comes up here, comes out of the monitor. So it's a 95 GPM nozzle at the top. From the monitoring station, they have a joystick, and they can move that monitor up and down, side to side. They can put it into a fog pattern, a straight stream pattern. So basically, as soon as a fire is detected, they're instantaneously extinguishing that before the fire department. Each customer has its own little SOG, standard operating guidelines. So let's say this is some bus terminal that has lithium-ion battery, it's charging stations. This box is 100% monitoring it, and they see that there's a fire. Then they bring up that customer on their computer. Step one is call the Abuja Fire Department, call this person, call the owner of the company, call the safety manager. And so they have all these protocols that are customized for each individual customer. So this makes for a nice solution if you have a large area that needs to be protected, like a charging area where you have 15 or 20 forklifts together. This could be a good system.
Fire Rover is the revolutionary way to stop fires before they begin. Using military-grade thermal cameras to detect abnormal heat variations and up to 20,000 gallons of firefighting agent, Fire Rover protects your business from property loss and downtime. Here's how it works. The thermal camera detects changes in surface temperature. Abnormal heat triggers an alarm and alerts Fire Rover's live monitoring station. Trained operators evaluate the risk and can trigger the firefighting agent remotely within seconds. Operators aim the firefighting agent using both thermal and HD footage. The firefighting agent is 100% biodegradable and effective on metals, petroleum, plastics, agriculture, rubber, general waste, and more, including lithium-ion battery hazards. Fire Rover can reach a distance of 150 feet with a radius of 343 degrees. The thermal camera confirms when the fire is extinguished and the surface has cooled, eliminating the need for costly fire watch. Fire Rover is always ready to detect and extinguish fires and keep your operations safe. Contact us today to start protecting your business.
So the real question is, are you ready to encapsulate the world, or at least let's encapsulate Nigeria? If that's the case, you are in good company. F500 is being utilized by all of these current companies that deal with lithium-ion battery. And I would say that, when you talk about Panasonic, Bosch, a new recent customer, SK Batteries, Tesla, Jaguar, BMW, Porsche, General Motors, Ford, Duracell. Those are some pretty high names in both the automotive industry as well as the battery industry. And this extends beyond that now. We have people like Georgia Pacific who's in the paper industry, but they have forklifts at their facility. International Paper, people like lumber companies, anybody dealing with lithium-ion battery, and pretty much everywhere is somebody who needs to be educated on the encapsulator technology. So here's the difference. You know, she's saying, wake up, Jack. And we're saying, hey, guys, jump on the life raft with us. And so I want to thank you for your attention. If we have any questions, again, we have Okama Affinity. Mr. Karajoki is on the line here with us in our webinar. We have also, again, Formed Hazard Control Nigeria. And so here's some contact information if you want to take a screenshot. But we're now going to turn this back over to Hernan. I'll leave the screenshot up here for a few minutes. And if you want to grab that, and turn this back over to Hernan, our host, to see if there's any questions or any questions in the chat. And I would just want to say thank you for your attention.
Any questions, please, from the audience? So we'd like to hear from you if you understand or you want to ask some clarifications. Wherever, feel free to ask questions.
Mike, some persons, not in this chat, but some person want to know about when you have a fire in lithium battery and you use water with A500. This water with A500 is danger to go to the to some place.
I didn't understand your question.
Can hurt the environmental?
Can it hurt the environmental?
Yes.
I think it's always good practice to contain all runoff from a fire, because the fire itself is toxic. And so while the agent is non-toxic, it's environmentally friendly, some of the things within the fire it's coming in contact with are toxic. So it should be looked at and maintained, and not just allowed to run down a storm drain. With that said, what we're seeing is, if we go back to the slide that was highly instrumented, in that fire extinguishment, we used 4.5 liters of a 2% solution of agent, totally extinguished the fire, controlled thermal runaway. That same fire, they discharged 50 liters of water, which creates the hydrogen fluoric acid, and they did not extinguish the fire. So I can't even say, oh, hang on a minute, we did 4, they did 50, that's a 12-to-1 advantage. No, it's way bigger than that, because the 50 liters did not put out the fire, did not. So may have used 100 or 200 liters. So I would ask that even if you have some toxicity from the fire, do you want to deal with a cleanup of 4 liters, or do you want to deal with the cleanup of 100, 200, 300 liters? And to me, that's the answer is pretty obvious that that you don't. We do know that we do not create hydrofluoric acid when we come in contact with the battery. In fact, we're currently working on a patent in Germany on that, because that is so significant that it's a patentable item, because you're reducing the cost of your exposure. We understand what's in that runoff, and we can take that runoff and put that through an industrial or municipal wastewater treatment plant. We can actually take the runoff, that 4 liters, we can dilute it down and put it to a wastewater treatment plant. The cost of that is minimal compared to picking up 10, 20, 30 times more and paying a disposal cost to send it to a processing plant.
Okay, wonderful. You explained before that some of the company are using this A500 to protect their facilities. I know the answer, but only to share with others. Do you know if this can be a solution for racks for three-dimensional fire?
For racks and three-dimensional?
Yes.
Yes. In fact, I know Tesla, they have their charging stations are in racks. If you can imagine, there's 25 racks. Each rack has 5 centers up. So 25 times 5, they have 100 batteries in there. The way the fire protection is set up, that is, if say rack number, let's call it column 4, row 4 is on fire, they know which one's on fire. They send that to the fire panel, and then it will sprinkle 4, well, the one above, the one below, and the runs to the side. So they're extinguishing. They're not just doing a deluge over the entire interior. They're identifying which rack has thermal runaway. They're putting that one out, and then they're putting F500 all around it, to the one to the right, to the left, the top, and the bottom, to contain. The ones around it are not impacted at all by the agent. It's just going on the agent. It's non-corrosive, non-toxic, non-harmful. So they're extinguishing that battery. And like I mentioned, I know they've had fires because we've gone back out to recommission the system, and you just don't hear about it on the news because it's just their way of doing business. Now, they don't have a ton as much. Like I said, the batteries are very reliable. So as many batteries as they process through that plant, they make the Tesla wall there. They make batteries that they ship to Fontana, where California, where they make the cars. And they have a new production facility coming out of the ground in Texas, which we're an integral part of with the construction team right now, to also have F500 at that facility.
Okay, wonderful, Mike. I don't know if somebody wants to make any question, Mr. Oladipo.
Yeah, good afternoon. This is from Nigeria. Good evening. I'm just trying to find out the F500, how does it really work in the oil and gas?
Okay. On the oil and gas, remember we have the spherical micelle. And so what we're doing is we're encapsulating the vapor that is burning. So if we take a look at a flammable liquid, what's burning is not actually the liquid. What's burning is the vapor. And then the heat from the fire is evaporating the liquid, creating more vapors, which is fueling the fire. So with the encapsulator agent, we're sweeping across the surface of the burning flammable liquid. We're encapsulating the vapors, those hydrocarbon vapors. So let's just say we're dealing with diesel fuel. So we're encapsulating the diesel vapors inside these spherical micelles, inside this molecular chemical cocoon. So we're separating the fuel from the oxygen, but we're doing it on a chemical molecular level, as opposed to foam that's forming bubbles and blanketing on a mechanical macro level. Two advantages of that. One, the spherical micelle is 100% the same every time it goes into the water, because it happens instantaneously and automatically. The foam, that's not the case. The foam, and we make foam, that's not the case. When you educt foam into the water, it's relying on the actual nozzles for the formation of the foam and the bubbles. Do you have an air aspirating nozzle versus non-air aspirating? Will greatly impact your foam. So what we're doing is we're encapsulating the fuel in the spherical micelle, separating the fuel from the oxygen on a chemical molecular level. And second, we're rapidly reducing the heat down below the auto ignition point. I mentioned two advantages. The first one was the consistency of the micelle. The second one is because we're encapsulating, we can actually do that in a three-dimensional environment. What does that mean? Means we work effectively on three-dimensional flowing fuel fires, three-dimensional fires like distillation columns, where foam, you have to physically put that blanket down on top of it. And so when we go back to the NFPA 11 foam standard, it says foam is not suitable for three-dimensional Class B fires. It's not suitable. It says three-dimensional flowing fuel fires and gas fires. So it's a big advantage for us. One of our big applications here in America is under turbine lube oil spray fires, distillation column fires. And when the new 18A standard comes out in February of 2022, one of the things that we're going to see is we have the ability to encapsulate the vapors without the fire ever being there. So we can actually put in proactive systems. Hernan is showing some videos here.
Yes, it's about three-dimensional fires.
Yeah, this is like a well blow off going into a pool fire. So you can see them sweeping around and encapsulating the fuel and cooling. Here, you couldn't put a foam blanket to separate the fuel from the oxygen because the fuel's coming down from the top. But we're using a wider dispersed pattern, lots of droplets, encapsulating the fuel, cooling this metal object all simultaneously to extinguish a three-dimensional flowing fuel fire. Currently, when you look at your NFPA standards, since foam is not suitable for this, you look and you see your three options are water, more water, and oh, holy shit, even more water. And we know water is not very effective. So here what we're doing is we're rapidly cooling and we're encapsulating the fuel vapors that are coming out of there and the liquid.
Mike, if I could share some on that same issue with oil and gas. After spending 13 years working in a remote oil and gas environment, most of it in the Gulf of Mexico on offshore facilities, and some of it in remote areas of the United States and Wyoming and places like that. The profound ability for this product to extinguish a fire, just to put this simple, is will make the difference between getting in a lifeboat and being able to stay on the platform. And getting in the lifeboat is a last resort, and nobody really wants to have to do that. So the difference between not being able to extinguish a high pressure natural gas fire or liquid hydrocarbon fire and being able to extinguish it makes all the difference in the world. Another application that I want to share is that in the offshore or even in any oil and gas production operation where you have vessels that are processing hydrocarbon materials and you have sludge and scale and whatnot building up inside of those vessels, I think our product has a fantastic opportunity to dramatically improve the safety and the efficiency of cleaning out those vessels, which has to be done periodically. And then the material that's cleaned out of those vessels would normally have to be disposed of in a hazardous waste landfill. And when the hydrocarbon material is encapsulated by the F500, it's no longer hazardous. So it's much easier to dispose of and transport.
And the other application that we made in Brazil, that's when they use for fires, they use the same product to encapsulate and remediate the spill on the ground or on the water. You can use the same technology for spill control, disgusting tank, and remediation that take a long time to remediate the spills. And with this product, you can encapsulate the hydrocarbon, and in short time, the bacteria of the ground can eat the demicell with the hydrocarbon inside. And you took less time to remediate different places, in sand, rocks, in everywhere.
Let me clarify one of the comments I made about cleaning out contaminated vessels. So
Yes.
you know that to clean out a 100-barrel hydrocarbon contaminated vessel, this could take days. To safe out the environment inside of that vessel can take many hours of ventilation. Once the decontamination process starts, your atmosphere can go bad on you again, and you have to back out and you have to re-safe out the vessel. You can go in with a solution of F500 and you can encapsulate the hydrocarbons inside that confined space, and they will permanently remain non-hazardous while you're doing your work. So you can change a multi-day tank cleaning operation into a hours, an operation that you might could measure in hours.
Yes, Ken, we have wonderful experience in different part of USA and here in South America. We changed to disgassing and cleaning a tank for 72 hours. We changed this quantity of hour with this product and equipment in only 2 hours. Yeah, Mike, I have a question for you. Can F500 be used in a conventional foam carrying fire truck?
In a conventional
Foam carrying fire truck. I believe that in a fire truck.
Yeah, the proportioning equipment is exactly the same. So if you have round the pump proportioners or eductors, that equipment is the same for foam concentrate as it is for the F500 concentrate. If that fire truck has nozzles that are designed to air aspirate the foam to create bubbles, then it will attempt to do the same thing with the F500. Remember, F500 technology is based on spherical micelles and droplets with mass that are intended to get onto a fire and not a bubble structure that tends to go up with the heat stream. So the answer is for sure on the proportioning side. It just depends on what kind of nozzles you have on your truck as to whether you would get the full 100% advantage of spherical micelle technology or whether those nozzles are trying to convert this into a foam. So I hope that answers the question. We'd have to take a look at the nozzles. So it's just not a straightforward, yeah, put it in, and it's just not a straightforward, no, don't put it in.
Yes, I don't know if I can share, Mike, and you explain me to Mr. Oladipo that the video of China.
Yeah, you want to bring it up again, the video?
Yes. This video is in China. Let me see.
Yeah, go back a little further. Yeah. Yeah, just start from the beginning. Because I can read the Chinese.
Okay, no problem.
So this is in Shandong province in China. China Fire Department, this is a large tank fire. We have 500 gallons. So this is about 1.5 meters deep of fuel. We're using F500 with one monitor. So it's flowing at, I think it's a 2,000 liter per minute, which is 570 gallons per minute. So this is the F500 demonstration. In China, the fire department is actually military based. So each province has their own fire department. We did 3 days of fires here with the military. So this is the F500. So you have over 1 meter deep of fuel just to eliminate the fact that it could be just a thin layer of fuel. One of the things you'll immediately notice when the F500 starts going through the smoke cloud, when he backs out, you'll see black smoke turning to a whitish gray. That's because the spherical micelle is inhibiting free radicals from coming together, which is what forms your black toxic soot and smoke. I apologize for the video. The guy kept going in to try to get a good shot of the smoke. And eventually he stabilizes here. So once we start to get the agent right across the top here, we're encapsulating the vapors. Total extinguishment in 58 seconds. About 16 gallons of F500. This is using the foam. Again, the same scenario, large tank fire, fuel and depth. Here they're using 2,000 per minute, 2,000 liter per minute monitors. So you can see one here in the foreground and one coming on the background. Now, when we watch this technique, on the F500, we were just kind of reining it over the top. Here, what they're trying to do is create a footprint along the side of the tank. Notice how that monitor now comes down and he's trying to cool the side of the tank because he can't get the bubble structure to bond off to the side. In the meantime, we have 2 nozzles from down below trying to cool the side of the tank right at that air, flammable liquid, and steel interface. So we're spending a lot of time trying to cool just to get the bubbles to seal off to the side of the tank, because what we're trying to do here is get a footprint of foam bubbles and let those bubbles spread across the surface. Here comes some other stuff in from the, like this is a third thing was coming in from the side. Did you just move that forward?
Yes.
Okay, man, I'm having a hard time following you, my friend. Can we go back a little further? Okay, you can see some stuff. Looks like a dry powder or something coming in from the side. I've been to China. That's not the Chinese water. But the minute it goes over the top, we get a quick knockdown. To me, that was like a dry powder. So we have a secondary agent that's used here that's not used on the F500. Now let's just let this run here. Again, we have the 2 monitors still trying to cool the side. We'll see here, we'll see some flame come up over the side of the tank here in just a moment. They're having trouble. You saw the black smoke. Now you'll see the top of the flame coming up because they're having a hard time getting this to seal off to the side of the tank. You see the flame coming up. So we have 2 different technologies. One technology encapsulated the vapors, takes all the flammable liquid out of the equation, cools the top surface of the liquid, and cools that tank very rapidly. So here you had 8,600 gallons of solution and 260 gallons of foam versus 16 gallons of an encapsulator agent. This is a no-brainer when you start looking at even over 7 minutes versus 1 minute, you've burned off more fuel in that 7 minutes. If you calculate that we're burning off so much fuel per minute, and depends on the fuel, and you calculate the quantity of fuel that burns off, you burned off more fuel in this foam application than it cost you to purchase F500. It's like getting free product just in the fuel savings and the difference between these two extinguishments. They're still putting foam on top because they have to maintain that separation for an extended period of time until you can cool down below the auto ignition temperature. F500, very rapid extinguishment, 16 gallons versus 260. The big thing there too is on the gallons of water, 500 versus 8,400. Sometimes you don't have room in your tank for 8,400 gallons. In that case, I've heard Williams Fire and Hazard Control say, well, sometimes you just have to burn off a bunch of your fuel just to make room for the foam. And we're saying there's a better way. There's a newer technology that's available that allows you to save that cost. Because the longer it burns, the hotter it gets, the harder it is to extinguish. The only thing that's good for is your foam fire suppression contractor.
Yeah. Okay, thank you, Mike. I don't see Mr. Oladipo. Maybe he leave the webinar. He received the answer.
No problem. I want to wish everybody a happy Thanksgiving. And if there's no other questions, I think we call it a webinar.